Okay, so let's do this video about how to access, subset, and download ERA5 reanalysis data in a NetCDF format to be read into the IDV. Okay, so we're going to select reanalysis data. If you don't know what that is, look it up. I've told you a couple times. And because we're going to analyze weather events, we need to look at data that's in the hourly scale. Now, that doesn't mean you have to download every hour. You could download every 3 hours, every 6 hours, for example, but it cannot be monthly. Daily is not ideal. Weather events propagate and change by the hour. Every 2 or 3 hours, you can see noticeable change. So we're going to select hourly data. Okay, so let's begin. So we're at the home page of the Copernicus Climate Data Store. There's where you need to be, right up there. Okay, so we're home. We're going to go to data sets. So far, pretty easy, right? Okay, now let's go ahead and, rather than scrolling through all these options, you can scroll through if you want to, if you got time, you're curious, which I would recommend at some other time. Let's see, product type, reanalysis, right there, boom. We're going to click that. Now, spatial coverage, global, boom. We're going to click that. We don't want to be limited to just Europe. Okay, so here we have options. We've got 13 options to choose from. We want ERA5, hourly data on pressure levels from 1979 to present. This is what we want. Okay? It says right here, ERA5 is the 5th generation ECMWF atmospheric reanalysis of the global climate. Reanalysis combines model data with observations from across the world to a globally complete and consistent data set. This is what we want. Not on single levels, because that would just be two-dimensional. Pressure levels is going to give the option to have multiple dimensions in height, multiple levels in height. Okay, so we want hourly on pressure levels. Okay, we're going to click that. Now we're taken to the overview page. Okay, so far so good. If you want to read all this stuff about ERA5 reanalysis, please do. We're going to scroll down. Here's some information about the data set. Here are all the variables that are available in this data set. Here are the units of these variables, and here's the description of these variables. It's important to be able to accurately describe the variable you are analyzing. So if you are plotting geopotential, and you might not have the best idea of how to describe that, well, there's your definition right there. Okay, let's select. Look at this. We have 37 pressure levels. That's a lot of vertical slices. Okay. Now we want to download the data. So intuitively, we go to download data. See how I click on that? Download data. Well, let me clear all these. This is from a previous. Just clearing everything. Clear, clear, clear. If you log in, all your previous stuff should be saved, which I should have started with the beginning. You will need to register and then log in before you select and download your data. So there's going to be a button up here that says log in and register. Please register first. It's free, it's simple, it's fast. Like most things, requires a username and a password. Couldn't be easier. So once you do that, then you just log in and your login name appears here, okay? So because I'm registered and logged in, I can now download until my heart is content. Okay, let's do this. We want reanalysis data, okay? We don't want all these ensemble members. No, we want the whole reanalysis data, okay? We're not looking at other things. I'm just going to pick a few random variables that I think might be important. You can pick whatever you want. I'm going to say geopotential, view component of the wind, V component of the wind, temperature, vorticity, and might as well look at divergence. Okay? Perhaps you're interested in some sort of specific humidity or some relative specific humidity or something like that. Yeah, okay? Potential vorticity, whatever. You can choose as many as you want. The more variables you choose, the larger your data set's going to be. Okay, keep that in mind. Pressure levels. I'm just going to start off with some standard ones: 1,000, 925, 850, 700, 600, 500, 400, 300, and 200. Now, if you want to do more vertical levels, you're welcome to, depending on what your need is, but these should give you a fairly good representation of the troposphere. Okay, so looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9 levels. Okay, pretty easy, right? Now, here's where you get to choose when you want the data selected. So, for example, if you have a case study in mind, say this event happened March 8th, 1993. Well, you'd probably want to get a few days before and a few days after. So maybe like March 6th, 7th, 8th, 9th. Okay, you could do that. Let's do that. Okay, 1993. Where are you? There you are, after 92 and before 94. Look at that. March. Day. If the event is on the 8th that we're going to focus on, let's pick 2 days leading up to it and a day afterwards. You can vary this. You could have 3 days leading 4 days after. It's up to you. It's just enough so you can capture what you want to analyze. Okay. Now remember, the more days you select, the bigger your file is going to be. Always keep that in mind. Okay. Time. You can select every hour of the day if you want hourly increments. That's no problem. But to keep the file size manageable, not too big, keep it under 100 megabytes, I'm just going to pick every 3 hours. 0, 3, 6, 9, 12, 15, 18, and 21Z. This is not local time. This is UTC time, okay? Now we get to pick what region. Boom, I pick select subregion. I already filled this out. This is just some random selection by myself. You will want to supply the extent of your region based on your case study. If you're asked to give a case study of something in a heat wave in Europe, you will not want these dimensions because it's going to be over North America. You will have to adjust accordingly, okay? If you want something over South America, these northern limits will not be good, okay? So these limits are something I just picked up. All this is just arbitrary, just to show you the example, okay? Now remember, the format, we want netCDF. IDV is going to read a netCDF like that, no problem. So anytime you do netCDF, the better. It's got all the header information packed into the file itself, so you have to do nothing to it. That is fantastic. All right, so we want netCDF. We've agreed, okay, license, terms of use, sure. Let's just double check what we're getting here. We're getting reanalysis data of these variables on these levels from this year, from this month, for these days, at these times, at this location. Okay, when you're satisfied with that and you want it in the netCDF, just go ahead and push submit form. Oh. And then it automatically takes you to the top line here, the date we submitted it, the duration. It's going to give you how big the file is and the status, okay? Now, I'm going to fast forward a little bit because I already did this. I'm not going to sit here and wait for the file to download. And we're going to look at this when I downloaded earlier today. It only took 2.5 minutes to download. It's 6 variables every 3 hours for maybe 4 days. Anyway, it's only a 60 megabyte file. When your file is finished downloading, you'll see a green icon that says download. All you do is you click it, and it'll automatically download to your download folder. Very simple. Okay, so then you're done. You have now learned how to access the Copernicus climate data page to identify what data you want, what data set you want, to tell it where you want it, when you want it, what variables you want, and what levels you want. You can control all of that. You tell it you want a net CDF, it downloads it for you, and you now have a file on your hard drive. Now it's important to remember where it goes in your downloads folder, okay? And it's going to have a funky name, okay? Like if I go show in folder, look at this, adapter.mars.internal dash blah, 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 blah. Okay, I don't know what that means. You know what I would do? I would go here. I'm going to go on this one because that's what I did first. I'm going to go in here. I'm going to rename it real quickly. I'm just going to do case underscore study example. Okay, you name it whatever you want. I'm just naming mine case study example. Okay, so now when I go to IDV, which is already up and running, look at me, all organized, doesn't happen often. Okay, here we go. Now we're looking at IDV. Now we want to say, IDV, let's open up that ERA5 reanalysis data set we just downloaded. So to do that, do you go to File, Open? No, you don't do that. Do you go to this little File, Open thing? No, you don't do that. To open a file, a net CDF file in IDV, go to Data Choosers. Make sure Files is highlighted in the left. You don't want URL, you don't want catalog, you want files. I just keep it out, I'm feeling lucky. To be honest, I don't know what that means. And if it doesn't work, if I was unlucky for whatever reason, I would go down to grid files. Or, yeah, I'd go down to grid files. Grid files net CDF right there, the second one. Okay. All these different options. But you know what? I'm feeling lucky. Okay. So where is it? It's in the downloads. What did I name it? Does anyone remember? Oh, I got a lot of download stuff in my folder. Let's go back and look at my downloads. Case study example. That's what I named it. So I go to the C's. Where are you? Look at all this junk I have in my downloads folder. It's embarrassing. I feel like it should be. Oh, where are you? Downloads. Let me refresh this. I'm just pretty sure. There it is. I had to push refresh. Okay. If you don't see it, just push refresh. Case study example right there. All I'm going to do is select it, add source, boom. It's loaded. We're ready to rock and roll in the IDV world. So let's see what we've got. Did everything download correctly? 2D fields? There's nothing. Because remember, we didn't select any two-dimensional fields. We didn't do single levels. We did all these variables were at 9 different levels, right? So they should be under the 3D button. Click the 3 button, boom! Divergence, look at that. We have everything. We're in business. So let's test it. Let's just map some stuff, okay? Let's have some fun. Geopotential, that's easy to map. I'm going to do contours. I always like to do geopotential contours. Times, here are all my times. In this case, I downloaded this earlier. I downloaded the first, the first 4 days of January 2019 at every 3 hours. Now you can see, because the default is highlighted, I could just do one if I wanted, but that would be pointless. So I'm going to do default. That's going to be all of them, okay? Level, let's go ahead and make sure we have all levels, okay? So we can change them if we need to. Region, here's my default region. Remember when I added those coordinates? Well, this is what the box I chose. That's good, that's what I wanted, okay? So geopotential, create display. All right, now IDV is taken away, okay? It likes what it sees, and what do you got? Look at that, beautiful geopotential height contours. What level is this? You want to have any idea? Ah, tells you right there, current level, 200 millibars. This is upper troposphere. Okay. Now, I always like to do some stylistic things at first, just to help me, because I don't like the black background with green. It looks too computery, too video game-like, and I'm not really into video games. So, color, view, color, black on white. Okay. Now this green map background, I like black. I'm going to click on default background, go to maps right here, click on that plus sign on maps. See where it says world coastlines? It's the only thing that's clicked. Click on the green, gives me this little color palette. I'm going to go to the black, click OK. Now, my coastlines, continents or whatever, are in black. I like that better. Okay, now we have color bar for contours. I want them all gray, for example, okay? I don't want color table. I want to go to solid, and I'm going to go to gray. Okay, and how do I like these spaced? I think that's a little too much spacing between the isobars. So I'm going to change that contour. Clicking contour change. Just going to delete all that garbage there, and I'm going to put 5 geopotential height meters. See what that looks like. Small, too small for the range. About 10. Too small. What about 20? Okay, now look, that's a little too much, right? See that? We'll keep it there. We'll keep it there. Why not? Why not? But you know what I'm going to do? Contour. I'm going to get rid of these numbers. I don't want to see all that garbage there. See what says labels? I am just going to deselect the label because I just want the pattern. I don't want the actual number. All right. All right. Apply. Numbers disappear. Numbers be gone. Okay. Now, if I wanted to get really fancy, I could name these. I'm just going to, let's do this for this one example. Okay. Z contour. Okay. What does this tell me? I don't know what this tells me. I'm going to go to the little identification property. Click on that. And display label. Boom, boom, boom. I am just going to type this geopotential height. What happens? Apply. Okay. Well, what do you know? Now, look at that. I wonder if the label can be in gray to match the color of the contours. Wouldn't that be cool? And it can. Look at that. Boom. Geopotential height. These great contours in gray. Couldn't be easier. You know what? I'm also going to change the legend here. I don't want Z contour plan view. No. Go back to this properties. And the legend label is right here. I'm going to change this to just geopotential height contours. I'm going to call it geo. I'm just going to abbreviate that. Hopefully it all fits. Okay. Boom. Okay. Now look at this. Now when I go to my list of things, I know exactly what it is. Geopotential height contours. There's my level. It's in gray, and I can move forward in time with my time driver here. Whoa! Something developed over there. What a coincidence. Good for this exercise. Okay, let's add some other things. How about some vorticity? Yeah, how about vorticity? Let's go to the field selector. Relative vorticity. I am going to do color shaded plan view. Let's get some colors on here. Times, all of them. Levels, all of them. Region, not messing with it. Vorticity, color shaded. Come on down. You are the next contestant. Okay, it's doing its thing. Yeah, look at this. Now, interesting. What happened to the coastlines? Well, coastlines are at the surface. 200 hectopascals is way up here, and it's a color shaded, so it's hiding the coastlines. I'm going to show you how to change that. Okay. Okay. Now we know relative vorticity can be positive or negative, and if something's positive or negative, I want a diverging color scale centered on 0, typically white in the middle. I'm going to change that up right here. clicking on that. It's my vorticity. Color table. Let's see here. I want to, now I have some extra color tables. You can get extra color tables if you look up IDV color table. Brian Mapes will show you how to add all these different color tables. And I'm using his diverging, and I'm going to go to blue, red, steep center. Look at that. Boom, everything is going from red to white to blue. So no, everything in the red's positive, everything in the blue is negative. But it's not equal. If you want to do that, if you want white to be 0, then the maximum and the minimum must be equal and opposite. Let's clean that up. Show what I mean. Okay, edit color table. The range is going to go from, we'll say, -7 times 10 to the 4th, 10 to the -4th, to 7 times 10 to the -4th. See how that's equal and opposite? Apply. Boom. Now everything is white is 0. I like that. Okay. So great. Here I'm going to play this. Watch the relative vorticity as we see at 200 hectopascals, as we see the geopotential height at 200 hectopascals move across North America. Okay. Let's clean this up for a second. I'm going to rename this just the way the same did the other one. Go back to properties, click on it, properties. I'm going to give it a legend name of just relative vorticity, so I can look at it and know right away what it is. And the label, let's just call it relative vort. And I want my label at the bottom to be red. Apply. Okay. Now look at this. Look how easy this is now, right? So I can just look at this down here, and it tells me everything that's already selected. Relative vorticity and geopotential height. And there they are. Take that off, it disappears. Okay. All right. Now let's get back to this continent business. Where are my continents? Well, if we're only looking at a 2D image, if we're not going to rotate this, then you can get away with moving the continents to the top. Okay. So default background, I'm going to click that. See the position? I'm sliding this from bottom to top. Boom, boom, right there, done. Couldn't be easier. All right, so here we're just doing some very simple analysis of 200 hectopascals. Let's add one more thing. Let's look at where the wind speed is between 60 and 100 meters per second at 200 hectopascals. Doubtful it's really 100 meters per second, but let's look at where it's greater than 60, and we'll shade that in with the rainbow. Okay, so first, let's map and notice I'm saying map. I'm not plotting, I'm not drawing, I'm mapping because I'm adding it to a map. So let's map the wind speed. Now, how are we going to get wind speed? Because we only downloaded the U and V components of wind. Well, that's all you need. You can calculate the wind speed from the U and V components. That's why we have them. Well, one of the reasons. So let's do this. We're going to go see on the field selector, 3D derived. See that? Derived. IDV is going to make this really easy for me. Look at all those things it can do automatically for me. Take a look. Look at that. Without me having to do any work, it's going to do all this stuff for me. It can if I want it to. But we're going to go speed from U and V. And I want speed and a color field contour. So here's what I want. Color field contour, all my times, all my levels, my region, create display. Now it knows where to look magically. I actually thought you had to locate it yourself, but it knows. Ah, look at this. It looks hideous. Let's clean this up. This is from 0 to 80 meters per second. We wanted only from 60 or greater than 60, okay? So this interval, 10 meters per second, let's make this 2. Oh, what happened here? We're gonna make this 2 meters per second. Apply. Okay. Okay, I like that. I like that contour interval a lot more. Look at the difference, right? Let's just give this a little play. Now what we're looking at is our wind speed and geopotential height. And what happened to vorticity? Well, because wind speed is on top, it's covering vorticity because you're at the same level, right? I could stop this, deselect wind speed, and my vorticity is going to be right there, okay? Let's now, here's what we're going to do. Only look at 60 and greater meters per second. Click on wind speed, go to the contour box, minimum value, 60, maximum value, let's go up to 100. Okay, apply, boom. What do we got? Okay. You know what happened? So there are going to be some times when it is less than 60, and that's why we see nothing. So go in the beginning, look at this, wind speed 60, okay? Now, I don't like this color scale. I want the rainbow not to go from 0 to 80, I want it to go from from 60 to 100, right? So let's get a color scale. So blue will now be 60 and not 0. How do we do that? Well, go to the color table over here, click wind speed, edit color table, and then here I want the new range to be 60 to 100. Okay, apply. But you know what? Since nothing's really going to be 100, let's bring this to 80, and everything over 80 will be red. Boom. Look at that. So now what we're looking at here is our 200 hectopascal geopotential height, relative vorticity, and wind speed greater than 60 meters per second. I'm going to play this. All right, look at that. Lovely, isn't it? Okay. Interesting, interesting. You know, if you were interested in something only between 0 and 20, you could do the same thing, right? See where the wind speeds are lighter. All right. Now I'm gonna do something a little tricky. This might not be the best application right now, but you will see moments or times when you will want to do this, okay? What if I want to make the wind speed semi-transparent so you can kind of see the vorticity underneath it, right? Remember, relative vorticity is there, but let's try and see it. So here I'm going to go to the color table of the wind speed, click edit color table, and actually I just saw something. You know, I've never tried this. Let's do this. Edit color table, transparency. That's what I was going to do, and it's right here for me. Let's go 70% transparent. Look at that. Look at this. It's semi-transparent. So you can kind of see maybe, okay? Now, this doesn't, like I said, this is not the best example to do here because we have a rainbow color over blues and reds, so you don't really, you know, kind of see it. But what this is ideal for is, say you want to look at, say, water vapor over precipitation. So you have a 2D precipitation field, and you want to lay over total precipitable water. You could make the total precipitable water semi-transparent, maybe 70% transparent, and you could see where the highest rainfalls probably line up with areas with the highest total precipitable water. Okay, so yeah, that semi-transparent stuff is helpful when you have multiple layers at the same level. You would try and see them all, right? Okay, so this is just a random kind of silly example. No, I'm not doing here a vertical cross section. This is two-dimensional. We can go through all kinds of different features of IDV ad nauseum when we meet in class. We can look at three-dimensional vertical cross sections. We can look at isosurfaces. We can do whatever you want. We can explore the built-in formulas. We can here all these. Look at these, all these different formulas that you can do. Okay. Look at these. Compute daily means. Blah blah blah. You can take a look at this time series, averages, integrals, make flow vectors, blah, blah, blah. But that's not exactly what I was talking about. You have an entire section, edit, formulas, Jython library, I believe it is. Yep. And here, my friends, if you go to system, grid routines, look at all these formulas we have. For example, wind shear, we can calculate wind shear. We can calculate a layer average of some variable, layer difference. We can calculate flow vectors. Okay, what else we got here? There are a bunch of different things here. We can also look at, I believe, grid diagnostics. Yes, we can add things, we can multiply things, we can divide things, subtract things. We can do the horizontal advection. Look at this, we can calculate horizontal advection. Okay, horizontal temperature advection. That would be great. We can do that in class. Average of two scalars. Okay, calculate absolute vorticity if it's not given, but I think it was given in ERA5. Coriolis parameter for all points on the grid. Look at that, you can calculate Coriolis. Total deformation, look at that, for you synoptic types that are looking at storms. Derivatives with respect to y, derivatives with respect to x, zonal derivatives, Marino's derivatives, whatever you're going to look at. Okay, you can go on and on and on and on and on, okay? What are some cool things we have here? Yeah, okay, so anyway, you get the point. Potential temperature from temperature, okay, we can calculate theta. Theta E, okay, all kinds of stuff. We can do this in person, okay? Yeah, so I think that should be useful for you. Please try this. Come with questions, come with examples. So we meet in class, we can have a very fruitful discussion and very informative. Okay, email me at any time, tallen@cimh.cimh.edu.bb. And I hope this helps. Okay, that's great. All right, signing off. Make sure you learned a lot so one day you can teach me, because there is a ton to learn here and I'm only scratching the surface. All right, have a good night.